Welcome! This is Algebra 2, Unit 3.7, Binomial Theorem, Pascal's Triangle. Oh, this is such an awesome way to raise binomials to powers. Now, I'm going to make you suffer a little bit here. Please abide by my video. I want you to take x plus 1 and raise it to the 5th power. I helped you out a little bit. I showed you it would be x plus 1 times x plus 1 times x plus 1 times x plus 1 times x plus 1. You will have to box and FOIL. So I did the first two for you. X plus 1 times x plus 1 came out as x squared plus 2x plus 1. Make my job a little bit easier, I just put that right into the next box. And now I'm going to take it times x plus 1. So I'm clear over the third one. Get it in the box. I get the answer. Because I ran out of space, I wrote it up here so that you can see it real well. Would you please take over? You're on the fourth one here. Pause the video. Get x plus 1. And do that one. Once you get that answer, you'll have to do it one more time. Pause the video. Please do that in your notes. Okay. Now that you've paused that video, I'm going to show you something really cool. I know I'm off task a little bit, but this is just an awesome thing. Pascal's triangle. It looks like this. You may have seen it in the past. Starts with a 1, and Pascal, he was a mathematician, and he came up with this, and it's just such an awesome thing. There are so many patterns in Pascal's triangle that I think that we have endless discoveries with it. It will be one of your projects or assessments is for you to research another pattern than what I show you today with it, okay? But this is just cool. So what he did to build it is he went, okay, 1 on the outside shell, so 1 plus nothing is 1, 1 plus nothing is 1. Then he put a 2 here. He gets that 2 by adding those 1s. Then he puts another 1 out here, another 1 out here. And in your notes, I should have handed you notes where there is a Pascal triangle grid so that you can just fill them in. It's really a nice grid, so make sure and search through your notes right now and fill them in with me. You can pause the video and fill them in on your own. So now the next row, we put a 1 on the outside. And we take 1 plus 2 is 3. 2 plus 1 is 3. Now we go another step, 1 on the outside. 1 on the outside. We go 3 plus 1 is 4. 3 plus 3 is 6. 1 plus 3 is 4. And that's our next row there. Okay, now we go down another row, we go 1. 1 and 4 is 5. 4 and 6 is 10. 6 and 4 is 10. 4 and 1 is 5. We have a 1 on the outside. I'll raise this up in case I'm coming off the screen for you. So next we'd have a 1 out here, then we'd have 6. 5 and 10 is 15. 10 and 10 is 20. 10 and 5 is 15. And 5 and 1 is 6. And I'm out of board space. Would you please pause the video and finish up your grid there or get several rows done? Okay, now coming back to Pascal's triangle, one of the cool things about it is on row 0, we can represent that 1 that was there as the 0th row, 0th term. In row 1, we can represent the 1 on this side as first row, or row 1, 0th term, row 1, first term. Row 2, 0th term, row 2, first term, row 2, second term. This has to do with probabilities and combinations, and we aren't going to get into them in our class, but I want you aware that it's here because when you do see this C in probabilities and combinations, you can think back to Pascal's triangle and look at the pattern that you've got, or this may be one of your research projects to look at combinations and probabilities with Pascal's triangle. Okay. Also, it goes into a little bit more of what we're going to talk about. So now, guess what? I could have made your job a lot easier on the first screen when I had you raise that binomial to the 5th power. Because look what happens here. A plus b to the 0th power is equal to 1. Anything to the 0th power equals 1. A plus b to the 1st power, this would actually be, 1a plus 1b. Okay? Now, we go to the next one. a plus b to the second power. That's 1a. I need to kind of show you my exponents on these to let you see what's happening. Here we had a to the first, and I didn't write it, but you could put a b to the 0th. The reason I don't write it is it wipes itself out. Over here, and I'll put this one in green now, you would have a to the 0th power, which wipes out, and b to the first power. That's why I didn't show that as 1b to the first power, 1a to the first power. But as we go down in this, it makes it really simple. Their exponents add to be the row number that we're on. So now this is going to be a to the second power. You always bring your front one and just start it at the highest amount, and then count down a to the first power and a to the 0th. Now, on the b, it would start at the 0 and count up. B to the 0, b to the 1, and b to the 2. Okay? I would go ahead and put, since it's a plus between these. And that way you don't have to entertain yourself multiplying these out. You've got the answer. You don't need to put the 0th power, so it's 1a squared plus 2ab plus 1b squared. Just wipe out your 0th power there. It makes it really handy when we get down to what you just multiplied on the first screen, because you're going to go a lot faster here. So now, on the third level, this would be multiplying a plus b times a plus b times a plus b. The answer will be, here we go, a cubed, a second, a first, a to the 0th. B to the 0th, b to the first, b to the second, b to the third. So again, my variables on my, or my exponents on my variables always add up to 3. 3 and 0 is 3, 1 and 2 is 3, 2 and 1 is 3, 3 and 0 is 3. That's my third row. Okay? And it just follows the coefficients are the numbers from Pascal's triangle. Put a plus between them, because we've got a plus out here. And now I would probably wipe out the 0th term. And there's my answer. Kind of cool, isn't it? Go ahead and pause the video and do this last one, then turn it back on and I'll have it done. Okay, there you go. Now another cool thing is if you were to wipe out the A and B there and put in L and R, you would end up with, let me make sure that is on my screen, okay, L to the 4th, L to the 3rd, R to the 1st, L to the 2nd, R to the 2nd, L to the 1st, R to the 3rd, and R to the 4th. Now you're sitting there going, well, that's really not that cool. It's just A and B is replaced with L and R. Not cool unless I'm asking you in Pascal's triangle to get to the 4th row. Now remember that's 0, 1, 2, 3, 4. So here I am, the 1, 4, 6, 4, 1. If you look up here, see I have the numbers already listed. There's only one route to get from here to here, always going down. Okay? You can't go back up. So always flowing downward, there's only one route. It comes straight down like that. There's the 1. Now, here, there happens to be 4 routes. All 4 have to do with 3 lefts and 1 right. So we could go looking at it, 1, 2, 3. Think this over. 1, 2. There's a 1 right. 3, 4. Ah! I can't remember how this goes. Oh man. I know what it is. I'm having such a brain fart. So this has only 4 lefts to get to it. This is so silly. I'm glad that I made the mistake for you though. This one has 4 roots to it. It will contain 3 lefts and 1 right on each one. So 1, 2, 3 lefts, 1 right. That's one path. Okay? Now, there are other paths. There's 1 right and 1, 2, 3 lefts. Okay? You could go 1 left, 1 right, and then 2 lefts. Or you could go 2 lefts, 1 right, and another left. Okay? So it shows you how many paths to each one of these. Whew! So 6 paths to that one, all containing 2 lefts, 2 rights. Wow, that was embarrassing. Okay, so again, it has to do with probabilities, pathways, and it does have to do with some logic that you'll get into in other math classes, but I just wanted you aware of that one. Okay, so now let's go back to one similar to the first one I gave you, but I wanted to show you with the negative what happens. So we would take, in order to find this answer, you could go the old-fashioned way and go s minus 2 times s minus 2 and do it 5 times like you did on the first screen. But I would suggest you use Pascal's triangle now. You know, this is your first term, so you fill it in here. S to the 5th, S to the 4th, S to the 3rd, S to the 2nd, S to the 1st. I'm not going to put s to the 0th power because that's equal to 1. Now the next thing that I would do, I would go negative 2 to the 0th. Oh, I'm not going to put that one. Sorry. Negative 2 to the 1st, negative 2 to the 2nd, negative 2 to the 3rd, negative 2 to the 4th, negative 2 to the 5th. Okay? Now, I will figure out my plus and minuses as I go here. This is 1s to the 5th. Negative 2 to the 1st is negative 2. Negative 2 times 5 is negative 10 s to the 4th. Negative 2 squared is 4, positive 4. Positive 4 times 10 is positive 40 s to the 3rd. Next one, negative 2 times negative 2 is 4, times negative 2 is negative 8. Negative 8 times 10 is negative 80 s squared. Negative 2 to the 4th power would be negative 8 times negative 2, which is positive 16. 16 times 5 is positive 80 s to the 1st power. And then negative 2 to the 5th power is negative 32. Okay, so that's your answer. If you wanted to work it out, doing all the boxes or all the foils, you would get the same answer. That's just a little bit easier, I think, using Pascal's triangle. And that's how you do it. You'll get lots of practice in class. Notice when you have a negative here, it goes every other one that you end up negative. Okay? So just kind of cool. You can spot it by when that negative value has an odd exponent, then it's negative. So here it had an odd exponent, that's why it's negative 10. Here it has an odd exponent, that's why it's negative 80. Here it has an odd exponent, that's why it's negative 32. Okay? Help each other out getting this. It's pretty cool patterns, guys.